Hello and welcome, people of the internet and programming enthusiasts. In this video, I'll show you how functools can help you write less code when validating inputs and make your type checking cleaner and more organized. We'll look at how to use custom decorators to validate data and how to write type-specific logic that's both elegant and scalable, all with the help of functools. Let's start simple. What if we want to validate a dictionary's keys being passed to a function? Suppose we want to ensure that every dictionary passed into our function has exactly 3 keys: name, age, and gender. If not, we want to raise a clear error. Let's create a custom exception and call it invalid key error. This is not necessary, but will help showcase how powerful functools actually is. It will simply receive a message, and a string representation of this exception will display this message. Now let's write a decorator to validate keys, and for this we will use functools.wraps to create a method decorator for this function. Using functools.wraps is like stamping your wrapper function with the original function's identity, but the wrapper function itself is still a single new function you write that handles the logic and passes arguments through. I know this is a lot, but let me explain. Our validate keys function is built on a few principles. Firstly, the decorator function, which is the outermost function, returns a decorator itself that accepts the original function. Inside this decorator, there is another function which wraps the original function and accepts any args and keyword args. Using functools.wraps, we copy the original function and all its metadata and create some additional logic that this function should handle. We then return the replicated function and the wrapper itself. Essentially, what just happened is that we replaced the function we wrapped with a new function with some of our own code that we injected to run alongside the original function. Now let's use this decorator, create a function that receives an argument, add a docstring, and just output the data itself. We will wrap this function in a try-catch block and handle our custom exception. Let's run this code and see what the output is. We can see the exception raised from our custom exception class, indicating that the data we tried to validate was actually invalid. By writing a method decorator and using functools.wraps, we can add reusable behavior like validation, logging, or error handling without changing the original function's code. Of course, we can always just write a decorator without functools, but when we do not get to the original metadata of the function. Notice how the docstring is none and the name of the function is simply wrapper. This keeps our code modular, readable, and easy to maintain, while functools.wraps ensures the decorated function still behaves like the original with the same name, docstring, and metadata. Now let's look at a cleaner way to handle different types of input using a single function name. Instead of writing a bunch of if-is instance checks, Python gives us functools.singledispatch, a way to define a generic function that behaves differently based on the type of the argument passed in. Let's say we're building a function that needs to handle different types of data, like a dictionary representing a user, a list of items, or a numeric ID. Each of these types should be processed differently, but they all go through the same top-level function, process. This works, but it quickly becomes cluttered as the number of types grows. If you want to extend this later, say for float, set, or a custom class, you'll need to keep modifying this same function. With single dispatch, we can separate out all those is-instance checks into individual functions, each one handling a specific type of data. Using a single function, we can break up the behavior of that function according to the received data type by adding a decorator called register. Instead of cluttering a single function with type checks, we register different versions of the same function name, and Python automatically dispatches to the right one based on the argument's type. These functions do not even need to be named, and each type-specific behavior is separated into its own function. To recap, functools.wraps is what we use when writing decorators, and it keeps the original function's name, docstring, and metadata intact even after it's been wrapped. This is essential for readability, debugging, and keeping your code maintainable. On the other hand, functools.singledispatch helps us cleanly organize logic based on input types. Instead of cramming a bunch of ICE instance checks into one function, we can register different versions for each type, all under the same function name. Together, these two tools let us write more modular, reusable, and Pythonic code without sacrificing clarity. Unfortunately, that's all for now. Thank you very much for watching. If you enjoyed the video, don't forget to like and subscribe. If you have any questions or concerns, feel free to leave a comment. Until next time, take care and goodbye.